Hi everyone and welcome back. When you are building software, especially for networking and automation people, you will quickly realize that the same types of problems keep showing up again and again. So instead of reinventing the wheel each time, developers rely on proven solutions that have stood the test of time. These are known as design patterns. So in today's lesson, we are going to explore two of the most important and practical design patterns that you will come across both in real-world projects and in your Cisco DevNet Associate exam. These are the Model View Controller pattern, also known as MVC, and the Observer pattern. But first, we will start with an introduction to common software design patterns, what they are and why they are so important, and how they work. Next, we will look at MVC, a classic architecture that's all about separation of concerns. You will also see how it breaks down an application into three clear parts. So you have the model, which handles the data and business logic. There is also the view, which controls what the user sees, and the controller, which acts as the bridge between the two. So this approach not only keeps your code more organized, but also makes it easier to scale, maintain, and collaborate on. Then we will dive into the observer pattern, which solves the problem of keeping multiple parts of your system updated at the same time. Imagine one piece of data that needs to update multiple dashboards, for example, or logs, or even alerts, all in real time. So instead of inefficient polling, for example, the observer pattern uses a push-based mechanism. So changes are instantly shared with everything that needs to know. Finally, we will then tie everything back to network automation. These design patterns aren't just theory, they are powerful tools that help structure large automation projects, make them easier to test, and also ensure that when your data changes, every system that relies on it stays in sync. So, from monitoring and configuration updates to generating alerts, you would see that why MVC and Observer matter for networking and why Cisco included them in the DevNet Associate exam. So stick around. By the end of this video, you will not only understand what these design patterns are, but also how they can make you a stronger, more effective network automation engineer. So now that we have set the agenda and outlined what we will be covering today, let's dive into the very first topic, which is an introduction to common software design patterns. Before we get into specific examples like MVC or the observer pattern, it's important to first understand what design patterns actually are and why they are used in software development and how they work in practice. So this foundation will make it much easier to see the value in the patterns we will explore later. So let's start by breaking down the concept of design patterns and the role they play in building efficient and reliable software. So first things first, what are design patterns? So design patterns are standardized solutions to recurring problems in software design. So instead of starting from scratch every time you encounter a familiar challenge, a design pattern provides a blueprint you can adapt to your specific context. They aren't pieces of code you simply copy and paste, but rather conceptual templates that guide how you structure your application. I want you to think of them as best practices distilled into reusable problem-solving techniques. In the same way that engineers rely on tried and tested approaches to build bridges or machines, software developers use design patterns to create reliable and maintainable systems. So the main reason for using design patterns is efficiency and consistency. They save developers from reinventing the wheel by offering time-tested approaches that are proven to work. This makes code easier to understand for teams because developers across different projects or companies often recognize the same patterns. So using design patterns also reduces bugs because the solutions have already been refined over years of practice. On top of that, patterns make it easier to scale and maintain projects. So as systems grow in complexity, structured approaches like design patterns help ensure that the application remains organized, flexible, and adaptable to new requirements as well. So, how it works. Design patterns work by abstracting common problems into generalized models. So, each pattern typically defines the rules of different components, their responsibilities, and how they interact. For example, a pattern might specify that one object manages state while another handles user interaction. So, developers then apply these concepts to their own projects, tailoring the rules to fit their needs. Importantly, design patterns are language agnostic. Whether you are programming in Python or Java or JavaScript or whatever the language may be, the underlying logic of the pattern remain the same. They don't dictate exact code, but instead provide a structure that guides how you approach design decisions. So, design patterns are usually divided into three main categories. These are creational, structural, and behavioral. So, the creational patterns focus on how objects are created, making the system more flexible and independent of how its components are instantiated. Examples include singleton and factory patterns. So, you would use a singleton pattern when you need a single source of truth or a centralized control point, for example. And a perfect example is a connection pool manager. So instead of every function connecting to a router, for example, on its own, you ask the singleton connection manager for a connection. This manager holds all the active connections and can reuse them efficiently. And most importantly, it ensures you don't accidentally open 5 SSH sessions to the same device when you only need one. Now, regarding the factory patterns, imagine you are writing a script to backup configurations. Your network isn't made up of just one vendor. You have Cisco iOS devices. You also can have Juniper, Junus, firewalls, and Arista switches, for example. The commands to get the running config are different for each one. For example, show running config for Cisco, show configuration for Juniper, and the factory pattern is your go-to tool here. It acts like a smart workshop that knows how to build the right tool for the right job without you having to know the nitty-gritty details. So with that being said, let's move into the second pattern category, which is structural patterns. So structural patterns, it deals with how objects and classes are composed to form larger structures. And that will ensure the system is both scalable and efficient. Finally, the behavioral patterns, and they are concerned with communication between objects and how responsibilities are distributed. They define clear ways objects should interact, making the system easier to extend. So these categories help developers quickly understand where a particular pattern fits in solving a problem and guide them in choosing the right approach for their project. So you might ask the question, why would this matter for you? And you need to know that in network automation, you frequently deal with changing device state, multiple consumers of the same data. These could be dashboards, alerts, CLI, and complex orchestration logic. So patterns help you structure those concerns cleanly. So your automation code is readable as well as testable and safe to run against production devices. And that's exactly why Cisco includes these topics in the DevNet Associate exam. They are practical skills, not just theory. So when we talk about Model View Controller or MVC, we are really talking about one of the most influential and widely used design patterns in software development. So MVC is all about separation of concerns, meaning instead of mixing everything into one big block of code, we split an application into three clearly defined parts, each with its own job. So the model is where all the data lives, along with the logic that manipulates that data. So think of it like the brain or memory of the application. If you are building a web app, for example, the model might talk to a database, handle calculations, or process input before sending back results. For example, if you are dealing with inventory in a store, the model is what keeps track of how many products are left, or updates stock levels, and ensures that information stays accurate. The view, on the other hand, is the face of the application. It's everything the user actually sees and interacts with. That could be a web page, a mobile screen, or even text output in a command line tool. The important thing is that the view doesn't care how the data is stored or manipulated. Its only job is to present the information in a way that makes sense to the user. And the beautiful part is that you can completely change how the view looks. So for example, redesign the web page, add a dashboard, or show data in a graph, for example, without having to touch the underlying business logic. Then comes the controller, and the controller is the middleman that makes everything flow smoothly. It listens to what the user wants to do, maybe clicking a button or entering some data or requesting a new report, and then it tells the model, hey, go fetch this information or update that record. And once the model does its work, the controller passes that result back to the view so the user sees the updated outcome. Now, why is this structure is so powerful? And the answer for this is so simple, because it creates a clean and modular architecture. If you need to change how your data is stored, you only adjust that model. If you want to revamp the user interface, you just update the view. And if you need new ways for users to interact with the system, you focus on the controller. Each part is independent but work together seamlessly. And here is the kicker. MVC isn't just an academic idea, it's everywhere. Frameworks like Django and Flask in Python, they all borrow from this concept. If you have used a modern web application, chances are it was built on top of MVC. For network automation specifically, MVC is a perfect way to keep automation scripts organized. So your model might handle network state data, the view could present dashboards or CLI outputs, and the controller can coordinate user requests like push this config or retrieve device status, etc., etc. So MVC gives us structure as well as flexibility and scalability. It stood the test of time because it makes complex projects easier to manage and helps teams collaborate without stepping on each other's toes. Now that we have walked through the MVC pattern and seen how it separates responsibilities into the model, the view, and the controller, you might be wondering, how do these components stay in sync when something changes? For example, if the model's data is updated, how does the view know to refresh without us constantly checking or writing extra code everywhere? And that's exactly where the observer pattern comes into play. It complements MVC beautifully by creating an efficient way to keep different parts of an application updated automatically. So the observer patterns is all about managing communication between subjects in a clean and efficient way. So think of that as a system where one object called the subject holds some pieces of data or state. Anytime that state changes, the subject automatically notifies all other objects that are interested in it. These are called the observers. So instead of each observer constantly asking, has the data changed yet? How about now? What about now? So on and so forth, which would be inefficient and wasteful, the subject simply says, hey everyone, something changed, here is the update. So this design pattern is often described as publish, subscribe, or one-to-many communication. So one subject can have many observers, and when something happens, they are all updated at once without needing to check manually. So how it works. The observer pattern is very simple. It only has two main components, the subject and the observer. The subject is the object being watched, and it maintains a list of observers that want to be notified when its state changes. It has methods like register to add observers, or remove to detach them, and notify to update them whenever something changes. Observers, on the other hand, these are the objects that care about the changes in the subject. So each observer implements a method, and often called update, and that runs whenever the subject tells them, hey, something's new happened. The observer doesn't need to constantly pull the subject. It just reacts when notified. This push-based communication style is what makes the observer pattern so elegant and efficient. Okay, so the real strength of the observer pattern is that it decouples the subject from the observers. So the subject doesn't really care who the observers are, or how they use the information, or even how many of them exist. Its only job is to push updates. Similarly, observers don't even care about the internal logic of the subject, they only care about receiving notifications and acting on them. So this decoupling has some huge advantages. So the first one is scalability. You can add or remove observers at any time without changing the subject's code. And the second benefit or advantage is flexibility. So multiple observers can each respond to the same event in different ways. For example, one might log the data, another might update a dashboard, and another might trigger an alert. And the last advantage is efficiency. Since updates are pushed paced, there is no wasted effort on pulling or constant checks. So I want you to imagine a subject that tracks the configuration state of a router. Every time the router's config changes, it notifies its observers. One observer could update a monitoring dashboard, another observer could write the change into a configuration database, another might send an email or Slack alerts to the operations team. All these things happen automatically in real time, without each observer constantly asking, did the config change yet? So we have now seen how the observer pattern helps keep different components in sync without relying on constant manual checks. It's clean and efficient way to handle updates. So on this final slide, we will connect the dots and see how MVC and Observer give us structure to large automation projects. And of course, we will also highlight their importance in the Cisco DevNet Associate exam. So when we bring MVC and Observer into the world of networking, the real value becomes clear. Networking automation projects can quickly grow in size and complexity. You might start with a simple script that logs into a router, but soon you are building workflows that gather data from dozens of devices. It can also push configurations in bulk or even feed data into dashboards for monitoring. So without a solid structure, that kind of code base can become a tangled mess. And this is where design patterns like MVC and Observer give us a framework to stay organized. So the first reason why MVC and Observer are valuable in network automation is that they provide structure for large projects. We touched on this earlier, but let's go over it again. So these separate your code into layers: the model to handle data, the view to present information, and the controller to act as the coordinator. So this separation ensures that as your automation grows, for example, pulling in device configs or parsing them and presenting them in both a CLI and a web dashboard, each piece has its place. So you don't end up mixing business logic with presentation code. Next one, it is easier to test and maintain as well as expand your code. So when logic and presentation are decoupled, testing becomes much easier. For example, you can test the model to make sure it correctly parses OSPF configurations without worrying about how that data gets displayed. Later on, if you want to add another output format, like sending data to an API, you can do it without touching the existing data handling code. So this modularity not only saves time, but also reduces bugs because changes in one area don't ripple unpredictability into others. Next one, it also enables multiple outputs from one data source. So this is where the observer pattern really shines. And I want you to imagine you have one model producing live interface statistics. With Observer, you can have multiple views subscribed to that data, perhaps a CLI view or a dashboard view, and even an alerting system that sends notifications when thresholds are exceeded, for example. The beauty is that you don't need to write separate polling logic for each output. The data changes once, and every observer is updated automatically. That's efficiency in action. In network automation, these patterns map directly to everyday use cases. So monitoring systems often use Observer to update multiple displays in real time. Configuration management benefits from MVC by cleanly separating the logic that retrieves and pushes configs from the interfaces used to trigger those changes. Finally, alerts and event-driven workflows also lean on the observer pattern, since one event, like a config drift, can instantly trigger actions across multiple systems. Finally, It's important to note that this isn't just theory, it's a topic you are expected to understand for the Cisco DevNet Associate exam. Cisco emphasizes these patterns because they are practical tools you will see in real world automation and DevOps environments. So, by learning MVC and Observer now, you are not only preparing for the exam, but also equipping yourself with proven strategies to keep your code professional as well as maintainable and scalable. So that's it for this video. I hope it was informative for you. And if you found it helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions or thoughts, feel free to drop a comment below. And to read more about this topic, be sure to check out my blog. You will find the link in the description below. And remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.